everyone. Welcome to my presentation. So today we are going to talk about lessons learned from building a GraphQL API on top of a large Django project. So my name is Marcin Gębala. I'm a Python developer at Mirumi Software in Wrocław in Poland. And I'm also lead developer at a project called Sailor. So for the last 2 years, I've been responsible for building and maintaining a GraphQL API at my company, and I'm also managing the open source community of Sailor. So the plan for today is as follows. First, I'd like to tell you a bit about my project, because that's how our journey started with GraphQL. Then we will go through some of the basic concepts of GraphQL and Graphene. And the main part of my presentation are some of the lessons that we've learned during building GraphQL API with Graphene. And lastly, we will talk about some problems and limitations of that framework. Right, so all started with Sailor at Mirumi. And what is Sailor? So this is the project that I'm building at my company, and basically it's an e-commerce platform. It's written in Python and Django, so it's like 100% open source. So you can take it from GitHub, you can customize it to your needs and do whatever you want. And what you get when you clone this repository from GitHub is these two applications. One is management dashboard for your staff users, and the other one is public storefront for your customers. You will also get the GraphQL API, which powers these two applications underneath. So you can use actually the backend itself if you need to build some custom storefront or mobile application or something else. You can use only the GraphQL. That's why we call it headless e-commerce. Right. So Sailor was initially built as typical Django project, like a huge monolith. With all the Django views and HTML templates, but at some point we realized that the static HTML views are not enough if you want to provide really good user experience and modern UI. So in order to compete with other e-commerce platforms, we wanted to build single-page applications for our front-end apps. So that's why we needed an API. And we picked GraphQL because at that time it was already, like, a lot of companies were already migrating to GraphQL, like Airbnb, GitHub, and Netflix. So, and we always wanted to try new technologies, so we decided to try it. So we ended up with this stack. So we have Django in the backend, Graphene API, like GraphQL API built with Graphene. We are using Python 3.6 and 3.7, so we support 2 versions right now. We have Postgres database, and our front-end apps are using TypeScript, React, and Apollo client for communicating with backend. Right, so now I'd like to talk about the basic concept of GraphQL a little bit. So first, how many of you is actually using GraphQL or have ever used GraphQL? Right, not so many, so that's why I think we should talk about the basic stuff a little bit. So GraphQL was created by Facebook in 2012 and open source in 2015, and basically this is a data query language for exchanging data between web applications, mobile apps and servers, etc. And it was created as alternative to REST. So REST has been around for many years, but it has some problems in modern web applications, such as underfetching, when we have to compose multiple requests, like data from multiple requests in order to render one page sometimes. We also have overfetching when server is sending actually too much data to our frontend. So GraphQL was created basically to solve these issues and also to improve a little bit the developer experience, to create some better tools. So we have 3 operations in GraphQL. We have queries for fetching data, We have mutations for modifying data, and we have subscriptions for real-time data exchange over WebSockets. This is really nice. And all operations are sent as post requests to a single endpoint, which is usually called simple /GraphQL. Right. We also have schema. So schema is something that defines capabilities of our API. So in schema, we define what types are available and what operations and like what queries and what mutations are available. To create schema, we use this language. It is called schema definition language. It's part of GraphQL specification. It's very simple. Like on these two examples, you can see, for example, how to create some basic types like product or user. And on the right, you can see how we can expose our queries or mutations. So all of these are actually objects in this language. We also have some types, like basic types like strings, boolean, floats, etc. And we can also create more complex types to model, to express our domain model. Right, so I've initially prepared a few slides to show you how queries looks like and mutations, but I thought later that this might be pretty boring, and it would be actually more interesting if I showed you this live demo. So you can also access this URL to play with the demo yourself, because it's available online. Okay, so I'm running Sailor on my machine here. And yeah, so I'm on localhost 8000 on /GraphQL, and if you have your GraphQL server running, you will usually get something like this. This is called Playground, and it's a GraphQL Explorer that allows you to play with API. So this is how a query looks like. This is the GraphQL format. So this looks a little bit like JSON, but it's a little bit simpler. We have these curly braces. We have field names, and basically this here, this is name of our query. We have one argument in here. This is the ID of a product that we would like to fetch. And this is base 64 encoded ID. This is a convention in GraphQL to use these IDs because like we have global identifiers, so every node in our API can be accessed with unique ID. And here we specify what fields we would like to get. So if we run this query, we are getting exactly these two fields. So we have some product name and description. So what can I do here? So if I hit Control space, I'm getting auto-completion. And I can see what fields are available in my type. So I can also fetch some related data, which actually underneath are different models. So we are using Django, so product is one model and category is a different model. There is relationship between them. So like in front end, it doesn't matter. Like we are expressing our domain model, not our database structure in here. Like that's the purpose of GraphQL. Right, so what we also can do here, like we can also fetch some related stuff. So actually, this is how our storefront looks like. This is pretty cool t-shirt, I guess. And imagine that you are building this app. So this is single page application. So we have one query to fetch this product data. This is our one table underneath in database. But let's say that we want to also display some related stuff, like to make the site more engaging and to do some upselling. So all of that can be fetched in one query. And in REST, I don't know, like it depends on your backend, but sometimes you would have to like send 3 different requests to compose all of this data. And it is the front end that is responsible for getting this data together, and you know, it becomes very complex. And with GraphQL we use something different. So for example, for my product, I can ask for the category and also for the other products in this category. I can use some This is how we use pagination in GraphQL. Right. And I have the data that I requested. So this is what queries can look like. And this is an example of a mutation. So it's quite similar. We have the mutation keyword here. We have a mutation name, and inside we define the input data for a mutation. So this would be, yeah, so we have a mutation to update a product. We specify the ID of this product and some input data, like what we actually want to change. Later, we have to specify what we want to get in the response. So we can ask for the product and all of the fields. It's up to us what fields we actually need here. We can also ask for some errors to get the validation errors. This is not a standard of GraphQL. Like, error handling is not very well, there is no specification for error handling. So you have to figure out yourself, and there is a lot of patterns. This is one that we came up with. I'll talk about it a little bit later. So if we want to update the product name, we can say, for example, hello Python X, and it returns us the changed name of the product. If we refresh this page, it works. Yeah, so this is how mutations look like. And what we also can do in this Explorer is, for example, to fetch all the types that are available in our schema. So this is called introspection. So this is some metadata that GraphQL exposes about your API. And this feature actually enables tools like this one. So this tool, for example, underneath uses introspection in order to show you the schema. So here we can actually browse through our schema. We can also see the docs. So these are basically the fields that are available in our API. Right. Okay, so that's the basics. I don't want to go in more details because if you are interested, you can read about it later. So how do we build stuff like this in Python? So the most popular framework at the moment is Graphene. And if you were attending PyCon last year, there was a presentation by Patrick about the basics of Graphene. And how does it look like? So just to remind you, Graphene is currently the most popular framework. It has over 4K stars on GitHub, and it has bindings for various web frameworks such as Django or Flask. And it basically looks like this example on the right. So we use classes to define types in our API. In Django, for example, Django integration with Graphene, we can easily map our models to types using meta classes. So basically what we have here is definition of three fields like customers, user query, or field that returns currently logged in user. And below we have three resolver functions. So in GraphQL, resolver is function that defines how to fetch the data from any data source. So this is powerful because you can either fetch data from your Postgres database, or if you have multiple databases or you use them for different purposes, you can easily implement it using those resolver functions. Right, so these are the basics. And you can read that in documentation, but now I'd like to talk a little bit about few things that you won't easily find in the documentation when you're building an API that is like more complex than a to-do list or blog, because that's what you will usually find in the tutorials, right? So let's start with the project structure. So in our case, because we were adding the GraphQL to app that we already maintained for 4 years or something, we decided to put our whole API into a single directory, which we called GraphQL. And if you take a look at this screenshot, it actually has multiple modules inside, and these modules are the same that we have in our Django app. So if in our Django app we had the account application, or product application, or I don't know, shipping, then we've recreated the same structure within the GraphQL directory. So that's the first thing, to divide your code in that manner. And then we have the api.pile file, which gathers all of this data from all of these modules and exposes it to the GraphQL schema. So this is how the single module look like. There is a bunch of files, but the most important ones are actually these four. So first we have types.py, which defines the object types that you've seen before, like these classes with field definitions and resolvers. Then we have resolvers.py. These are only the simple Python functions that tell our fields how to get data from database. So sometimes it's not so simple, like getting all of the records from database. Sometimes you want to do some pre-processing, post-processing, some annotations and stuff. So to keep it clean, we have all of this in one file. Then we have mutations.py, which define all of the mutation classes. I'll show you how to define mutations a little bit later. And lastly, we have schema.py, which gathers all of these and exposes it further. Right, so if you are building a web application and you have an API, you probably want to also have some authentication. So in Graphene, by default, there is no way to have authentication. Like you could use the Django auth, like session auth or something like this, but that's not usually the case with APIs, because in API you usually want to authenticate particular requests, right? So the pattern that is often used by different applications is JSON Web Tokens. And we can use it in Graphene by installing this library called Django GraphQL JWT. And what it does, it gives us this mutation, which is called token create. And it takes user credentials as arguments. So in this case, email and password. And it returns the token in the response. We have also modified this mutation a little bit to also return the user data, because usually in single page you want to render some user data when they log in, like, for example, first name, last name, or their avatar. And a response might look like this. So we are getting the token, and we are getting some user data. So with this token, we can simply pass it in the authorization header, and every request that will have it, and if the token is correct, will be authenticated, and user will be able to perform the action. So with this library, we can also restrict access to particular fields. So by default, in our schema in GraphQL, all fields are public, right? So people can query for every field, and sometimes you actually want to restrict access, because some of these should be used only by your dashboard application, for example. So with this library, you can use these decorators to restrict access, right? So if you are using Django, this is very similar, because I think that we have exactly the same decorators in Django to limit access to our views. So it's nice about Graphene that it reuses the same patterns that we have in Django, so the code is pretty familiar. So after building this API, it turned out that the most tricky part are actually mutations, because usually they require like a lot of different code modifications, like a lot of different use cases, validations and stuff. So by default, this is how the mutation look like in Graphene. This is a very simple example. It is called add product, so you can imagine that it is used to create new products in our database. And what it's happening here, like we have first the definition of what will be returned if this mutation succeeds. So we are getting the product instance. Here we defined the input data for that mutation, and this is part of the Graphene API mutate function, where we actually implement our logic for this mutation. So this is called a mutation resolver. And as you can see, this example is very simple because it just takes the input data from the mutation and puts it into the model instance and saves it. So that's not usual case. Usually you want to have some validation of the incoming data. Also, you may have some validation of the product instance or the model instance. And if you were using the basic mutation class that is provided by Graphene, you will end up with a lot of boilerplate code. So especially if you have like 150 mutations in your code. So what can we do about this? Of course, we build abstractions. Developers love abstractions, especially in Python, where it is really easy to create flexible code. So the first thing we invented was this base mutation mutation. And what it does is it defines the errors field at the response. And you can see on the right how the error type actually look like. And we've modified a little bit the mutate function. So we've added the perform mutation class at the bottom, function. And this function is called inside the mutate, right? And it's also wrapped with try except. So we can raise different validations errors from inside perform mutation and don't care about them later because they are handled inside the mutate function. So when any validation error happens, we convert them to this structure and return them as a response. So what's nice about this is that we can only focus on the positive case, like if something goes wrong, we just raise validation error and that's it. And mutation execution stops right there. So that's the first abstraction. The next one, when you're building the dashboard application, you will quickly notice that most of your mutations are simple CRUD mutations like creating, updating, and deleting stuff. And creating usually follows the same pattern. So first you want to clean your input data, do some validation. Then you create the model instance. Again, you can do some validation. And if everything is OK, you save the instance. So we've created this small abstraction called model mutation. This is only the most important part of it, the perform mutation function. So this class basically implements all of these 4 steps. So we have, if you take a look at perform mutation, we have these methods like clean input, construct instance, and clean instance that do actually these 4 steps. So if we want to modify any particular step, we can simply override this function. So a mutation that would implement this model mutation abstraction would look like this. So it's very simple. The same case is for mutation that delete objects because they are very simple and they usually follow this simple pattern that first you want to get the instance and then delete it. So it's very easy to add similar abstraction for that. So it is called model delete mutation, and what it does, it finds the object by ID. This is small utility that we wrote, get note or error, which is similar to get object or 404 in Django. Also to either get the instance or raise an error if, for example, the ID is incorrect or something like this. And we simply delete the instance. So this is how a particular implementation would look like. Unfortunately, these abstractions are not part of Graphene yet. There are some other abstractions in Graphene, but we will talk about it later. And the last, I think, very interesting problem is database query optimization. So when you are building your API, you want it to be fast, and paying attention to database queries is very important part. So imagine that we have these models, like we have product and their images, and there is a relationship between them. So product can have multiple images. So to fetch that in GraphQL, you would use a query like this. That's example from our schema. We have a thumbnail field, which underneath takes the first image from this relationship and returns it. So front-end doesn't know about this, right? So this is great for the front-end, but it's usually nightmare for back-end because we have to somehow support that. And what happens here is if we don't have any optimizations, if we are rendering a list of products, then we have like duplication of database queries. So if we are fetching only one product with this query, we will get two database hits because we have to fetch all the products, and for each of them we have to fetch an image. But if we have like rendering a product list, and we have, for example, 20 products, then we have 21 database hits. So that's really bad. And there is one library which is called Graphene Django Optimizer, and what it gives you is these decorators. They are called resolver hints, and you can use them to prefetch data from different tables. And this is really nice because it will only run when you asked for this field. So if we have the thumbnail field in our query, this optimizer will run this prefetch related. And if we don't fetch this field, it will only use this simple query to get products. So let's talk about the problems of Graphene. So there are a few problems. As you may noticed, we are using at least three or four additional libraries. So some of these features are not part of Graphene yet, and you need additional libraries, and they are not very popular ones. Like they have about 100 stars on GitHub. So they do their work, but if you are using that in production, it's sometimes difficult to trust these libraries because you will never know if they will be maintained or not. There are some crucial features missing, like calculating query costs is impossible in Graphene. So user can send very malicious query to your server, like very deep nested queries, and there is no way in Graphene to tell how expensive they are. In other frameworks, I think some of them implement that in different languages. And also you cannot serve multiple schemas at once easily. I guess that would be possible with some hacks, but it's not by default. So if we have private schema for our dashboard app and public schema for our customers app, like we can't serve them both at the same time. So we only have one schema, and one downside about it is that everyone can see the schema, right? So even the private fields are exposed. They cannot be accessed, but they are exposed still. Another big problem are maintenance issues. So currently there is a lot of open issues and pull requests in the Graphene repository, and actually the main contributor and author of that framework is like not maintaining it anymore. He's busy with some other project, and there is a group of good people that are trying to form some group of governors of that project to keep it working, because a lot of companies is now using Graphene really, and this is very good project, and like it shouldn't die like this. Another problem is that there is lack of good resources, so the documentation is not very well, is inconsistent in some places, and yeah, it's like you have to give a lot of tries to understand what's going on. So that's another problem, and there is also a lot of non-Pythonic concepts in the source code, like this one. This is user loader. This is a idea taken from JavaScript. It's implemented in the original implementation of GraphQL, but it's actually not very Pythonic, right? We don't have promises in Python. We have async await, and that's what we should use here maybe, but like there is a lot of ugly places inside Graphene, and sometimes when you need to when you're writing these abstractions, you have to read through this source code, and it's sometimes really messy. Okay, so summary. I think that anyway, GraphQL is a great tool for data exchange, and we should use it. So it's great for front end mostly. In my opinion, for backend, it's not so much difference, because if you are writing REST APIs or GraphQL APIs, we still have to deal with the same problems or similar problems. So it doesn't matter. But most of the benefits are on the front end. So front-end libs for GraphQL are just amazing. So in the front-end, you don't have to no longer care about multiple HTTP requests to different endpoints. You don't have to care about WebSockets because you have subscriptions. You don't have to care about like a lot of other problems, and that's the biggest power of GraphQL. Another point is that Graphene allows you to add API gradually, so that's what we did. We still maintain our old Django views and application, but we were covering all modules gradually, one by one, and it took us about over a year, but we eventually made it. So you can start adding Graphene gradually. So as you've seen, the future of Graphene is uncertain, but there are new libraries emerging. And despite all of these limitations, still, Graphene is the most advanced framework for GraphQL in Python right now. And my advice is that if you are using Django, I think that you can stick to Graphene for now and see and observe the repository and see what's going on in the community. But if you are using Python and you want to try GraphQL, you can use some other libraries. And here is a bunch of resources for you. So the first four are the libraries that we use. The next two, Ariadne and Strawberry, are the other GraphQL libraries that showed up quite recently. One was presented yesterday at Lightning Talks. They use two different approaches. You can just take a look and pick whatever whichever you like. And lastly, there is these are the links to our project. If you are interested in taking a look how the Graphene code base look like, you can take a look at our repository, and that's it. Thanks a lot.
Okay, we have time for a few questions. There's one in the back.
Thank you, Marcin, for the great speech. And just for a sneak peek on the front-end side, okay, would you suggest any good practice to keep the front end dry? And because I never used the Apollo client before, but I guess the types in Apollo go well with the TypeScript interfaces and types, okay? So would you suggest any good practices to keep the front end well maintained while the APIs, the GraphQL APIs are still being developed?
Okay, so if you are using TypeScript, like you should use TypeScript or Flow. That's the first rule, because with that you gain the type generation. So you end up with the same types in front-end as in backend. Well, you can also use deprecation. So if your API is changing, you can always deprecate field in the backend. And the nice part about the tooling is that the tools will tell you that you are using deprecated field. So you will get the warnings. So yeah, that's how we do changes in our API. Unfortunately, you cannot deprecate, for example, input types or mutation inputs. That's just the limitation of GraphQL, and there is an open issue in the GraphQL specification even. So maybe they will fix that. So that's it. I'm not a front-end dev, but that's what I know about the front-end tools.
In our company, we mostly use asynchronous solutions like HTTP. What's the kind of support for asynchronous servers and GraphQL right now in Python?
So I don't know about Strawberry, actually. So Patrick will tell you more about this.
Yeah, so I'm working on a library called Strawberry, and that's async first, so you can just use async whenever you want. That works. I think on Graphene you can also use async with the, you need to change the
GraphQL core next, probably.
Yeah, you need to use basically the underlying library. You need to change it. I mean, it's just like an option in the when you set up the schema, and it's gonna be async.
Yeah, but you cannot use async with Graphene Django, for example, because Django is synchronous. But also in the previous, this other library, Ariadne, is actually developed by my company, and we are experimenting with async. And there is the Starlet ASCII framework, if you've heard of it, and it supports it's a web framework for async, and we are trying to plug it somehow. So you can try this as well. So the good thing is that there is new and more tools for async emerging already. So I recommend following Tom Christie, who is author of Django REST framework. He's creating a lot of good stuff for async computing, like async ORM events. So that's the future of Django and Python.
Is there any other question? Cool. Thank you again.
Thanks.